Okay, so again, talking about line symmetry. So if I just drew, come on, just a line straight down. Okay, well, obviously Mrs. Smith is not an artist. But if I drew a line straight down and I took this and I kind of folded it onto there, it would all line up. That's line symmetry. Now this next part, degree of rotational symmetry, that is a big deal. So before you can apply the formula for the degree of rotational symmetry, you need to determine if the shape has rotational symmetry. See the definition below. To calculate use 360 degrees and divide it by n, the number of vertices. This, star it. Feel free to add this to your foldable too, so you have access to it. That's the one thing that's not in your foldable. But what we would say here is, just as a idea, let's say they tell us we have a regular, max enough, regular pentagon. How many sides does a pentagon have? 5. Regular means that has all angles are equal and all sides are equal. So we would take here for that rotational symmetry, we would take 360 and divide it by 5. And then we would have that rotational symmetry, that degree of rotational symmetry. Okay? We are going to see this formula again, but in different contexts. Okay? Right now it's rotational symmetry. It'll be, it'll also act as like total degrees in a polygon, but you're going to see it again. It's just going to have different meanings. Okay? All right, now let's get into actual rotational symmetry. So this is telling us that a figure has rotational symmetry if the figure can be mapped onto itself by rotating a figure less than 360 degrees about a center point. So think like a pinwheel. So in this case, what they're saying here is, just to give you an example, like that would look similar on your test, if they gave you the letter E. Now, if I put a point directly in the middle of E, and I rotated this, is there any way that E is going to map back onto itself before reaching like a full circle? No. So the letter E would have no rotational symmetry. Okay? However, this guy, if we look at it, we can see here, if I kind of connected these a little bit, I would have a, let's see, 1, 2, 3, 4, 5, 6, 7. Looks like an octagon. Very octagon-ish, right? So if we look at this, now, if I put a point directly in the center of that and I rotate it, will it map onto itself before we hit that full circle? Yeah. In this case, it would be 360 divided by 8 total vertices. Who can tell me what's that going to be? Bryn? 45 degrees. So that's the difference between rotational, that's what rotational symmetry is. There's a point in the center, and we're trying to see if it circles on back onto itself at some point. Okay? Questions on that? Okay. Let's move on to our first few examples. I'm going to delete that. All right, so determine if the figure has line and or rotational symmetry. Check all that apply. If the shape has rotational symmetry, find the degree. So if we look here, we see that we have a hexagon. So a hexagon definitely is going to have rotational symmetry. Like if I put that point in the center, it's going to map back onto itself, right? So we're going to take 360 divided by 6. What's the degree going to be there? Yeah, 60 degrees. Very good. Okay, now the question is, does this have line symmetry? So now we're saying if we draw a line through this and we fold it onto itself, will everything match up, right? So if I went like this, would that work? Yeah. What if I went through these vertices? Would that work? Yeah. So if I keep going with this idea, I'm going to go through the vertices, I'm going to go through these sides, I see that there's quite a bit, and this gets a little kind of mushy, like weird, real quick, right? So here's my recommendation. I would just label these. Here's line 1, 2, 3, 4, 5, and 6. And then once we hit where we already marked, we know that we don't have to worry about that. So this has a total, this has line symmetry, and it actually has a total of 6. 6 total lines. Questions on that? Yeah, Max.
So since we divided 360 divided by 6,
Mm-hmm.
does that mean like the lines are equal to like what we divided it by?
Sometimes yes, sometimes no. It really does depend on the shape. In this case, since it's regular, yeah. But we're going to run into some other shapes that are irregular, so we can't always assume that. A good question. Yeah. It does. This one does have both. Yeah. All right, let's take a look at this next one. So we're gonna take a look at all the odds. Where did my stuff go? Why did it do that? Oh, that's weird. All right, so in this case, if we take a peek, we can see, now the question we need to ask ourselves is that, where did my drawing tools go? Why is it doing that? That is so weird. Okay. Okay, here we go. All right, so if we take a look, all right, so in this case, let's first think about rotational symmetry, because that's usually the hardest to visualize. Again, I put that point in the center, and I rotate this. Now, if I rotated it to this next vertex, that would be 90 degrees. Is it going to map onto itself? No. So what if I do another one, and I hit all the way to the opposite side? That's 180 degrees. Now will it rotate onto itself?
Yeah.
Yes, it will. So this has rotational symmetry of 180 degrees. This is different than using the formula because this is not a regular shape. So sometimes you got to visualize it a little bit. Okay? Does that make sense? A lot of times, though, it's either like, if it has 90, you can calculate it. If it's 180, something else is happening there. Okay? All right, now line symmetry. The thing we need to ask ourselves is this. I'm just going to clear this real quick. If I drew a line here, would it map back onto itself? Not really. This would land kind of here, and that would land kind of there. And if I drew something down the middle, would it land on top of itself? Not really. So in this case, this just has rotational symmetry, and we're just going to say 180 degrees. That's it. Questions on that? All right, let's take a look at the star. If we look at the star, and let's work with that rotational symmetry first. Again, I put a point in the middle. Will this map onto itself before 360 degrees?
Yes.
Yeah. The question is how much. And if we look, one thing, this is just a tip or trick. If I draw this out, it looks like a pentagon, right? So it's going to have rotational symmetry, and it's going to be 360 divided by 5. What's 360 divided by 5? 72. So this will have 72 degrees of rotational symmetry. Now line symmetry is going to be a little different. If I look here, if I put a line straight down the middle, will it fold onto itself? Yeah. What if I drew a line through that vertex right there? Will it fold onto itself? No, that one won't work. However, this one will work, and this one will work, and this one will work, right? I'm trying to say, I know I'm missing something. And this guy, and this guy. So again, lots of lines here. I'm just going to label them. 1, 2, 3, 4, 5. So this has line symmetry as a total of 5. It has rotational symmetry that we calculated of 72 degrees. Yes?
We have to write how many, like the line part, do you have to write how many?
No, but it's on your test that they're going to ask you how many lines of symmetry does this have. So that's why I'm doing it. Does that make sense? But in your homework, if you don't do it, I'm not gonna like hold it against you, if that makes sense. On the test though, you gotta know. Or it'll ask you like, here's all these different lines, which ones are actual lines of symmetry, and then you'll have to like select all that apply. Okay. Questions? Okay, let's take a look at letter A. So letter A, again, this, if we look, if I, again, put a point directly in that center, and it rotates, is it going to have rotational symmetry? No, not in this case, so no rotational symmetry. However, it could have line symmetry, right? What if I drew a line right here? Would that fold onto itself? Absolutely. So this has line symmetry, and we're not even going to worry about labeling that because we don't have rotational symmetry. Does this make sense? Yeah, pretty easy, right? Once you get the hang of it, I mean. Okay. Here's what I'd like you guys to do. I want you guys to kind of look at these. Okay? Now remember, some of these have a shape. I want you to just do the odds real quick. We will discuss them in a few minutes, all right? But 9 through 19 odds only, okay? Give it a shot. So it is 1, 2, 3, 4, 5, 6 total. Give those 6 a shot, and then we'll go over them in a minute, okay? 9 through 19, odds only. Odds only. Not evens, just odds. Okay. What the heck is it? This thing is so weird. Yeah. Yeah, you can work together. That's fine. Just stay in your seats, though. That's all I ask. Yeah.
So for the rotation, is it like the whole shape, the original shape, or is it the circle,
No, we were dealing with the shape. I said circle because if you hit 360 degrees, there's no rotational symmetry, so it does hit that whole, like it circles all the way around. Yeah. So if you start like with that letter A, right? And it starts here, and you try to rotate it and rotate it and rotate it and rotate it, but it doesn't hit anywhere where it still looks like the same shape before 360 degrees. Does that make sense? So that's why that A had no rotational symmetry. But the hexagon did, because if we mapped it just that little bit, that one vertex on this side does map onto that other, and it keeps the whole shape. Does that make sense?
Bro, I have a bunch of
You make a pass? Make a pass real quick. Yes, please. All right, let's go over these real quick. All right, so for number 9, if you take a look, okay, if I kind of drew this, now this is not really going to have line symmetry, but if I connected these vertices, it does have rotational and looks kind of like a square. So it would have been 90 degrees here. Now for 11, we're kind of dealing with the same idea as that letter A, right? In this case, it was the letter R. There's neither here. Okay? It doesn't matter where I draw a line, nothing's going to map back onto itself. And if I put a point in that center and I rotated it, it's going to hit 360 to get back to its original shape. Okay? Questions on those two? All right, 13. This one, if you kind of connected these vertices, it would look like a triangle. Okay? So if I did kind of like that, you'd get like something very triangular. So, and very regular also. So that would be 120 degrees. And then the line symmetry is right there for you guys as well. So I had like 1, 2, I think 3 lines. Okay, so this one I'm a little bit more, this one could have been taken kind of 2 different ways. All right, I'm going to show you. If you looked at this more like a square, you would have gotten 90 degrees. However, because it was brought to my attention before, you could kind of also view this as kind of octagonal. So it would have worked either way. If it was an octagon, yeah,
Can I get some of that?
after this. If it was an octagon, you should have gotten, I got 45 degrees, okay? So that one's got a little bit more leniency only because you could have seen it either way, okay? However, the lines of symmetry did not change. Uh, 17, this is none. There's really nothing here you could do with that one. And 19, this would have rotational symmetry, but not line symmetry. So again, putting that, again, it looks very triangular, so it would have been 120 degrees. Questions on this? Oh, 17 was none. Yeah. There's nothing there. Sure. Wait, 12? We didn't. Oh, we didn't do 12, but. Okay, there you go. 10 only had. 10 had a second one here. It actually. It's not just not a key. You could have also had a line like that. But it would have had both.
Couldn't we have a line like this in 12?
No. No, because if you look at it, ooh, let me clear that out. If you went straight, there's no way you can go straight across it. Like this point would probably land like about there if you flipped it over. That's all. There's nothing there. It's gonna land somewhere in that shape. And even if you made it all the way to here, these won't line up. They're gonna be kind of cut off there. You know what I mean? So, any other questions?
Can you go back up to 10?
Yeah. 10, just remember it has that error. It has one that goes up and down too, so there should have been 2 lines of symmetry there. Anything else? All right, homework. All right, this is your homework. All right, 1 through 12. And you're going to post it immediately so you don't have to worry about it. Sound good? All right, have at it. Those who are watching at home, have a great day.